Welcome back to Generative AI 101, the podcast where we take the complex, often perplexing world of AI and generative AI and turn it into something you can actually understand. This week, we're going to progress into our deep learning mini-series. So I'm Emily Laird, your guide through this digital funhouse. Today, we're diving into Neural Networks 101, a foundational part of our deep learning mini-series. Buckle up, folks. This ride's about to get bumpy, but I promise we'll have some laughs along the way. Let's dive in. Welcome to Generative AI 101. All right, let's talk neural networks. Think of neural networks as the brain behind the operation, literally. They're designed to mimic the human brain's network of neurons, but without the annoying habits of forgetting why you walked into a room or procrastinated on Netflix. Imagine if your brain was as efficient as Google search results, and you've got a rough idea of what we're aiming for. So what are neural networks? Neural networks are a series of algorithms that attempt to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. Picture a spider web of interconnected neurons working together to process information, and instead of catching flies, they're catching patterns and insights. There's some key components that go along with neural networks, so let's walk through those. Neurons. So neurons are the basic unit of a neural network. Think of them as little data processing gremlins, right? Each one taking an input, doing some magic, that's mathematical operations, and then spitting out an output. Then we have layers. Neural networks are organized in layers. There's the input layer where data enters, hidden layers where the magic happens, kind of like MTV Cribs. No. And the output layer, where the final result pops out. It's like making a sandwich. Bread is the input, fillings those hidden layers, and more bread, the output. The more layers you have, the more complex and maybe tasty your sandwich gets. Then we have weights and biases. These are the secret sauce of neural networks. Weights determine the importance of inputs, while biases add that extra zing to make sure the outputs are just right. Imagine making guacamole. Weights are the perfect avocado to lime ratio, and biases are that dash of salt that takes it from good to guactastic. So how do neural networks work? Let's break it down with an example. So imagine you're trying to teach a neural network to recognize cats in photos. Like your crazy aunt is back again. She has boxes of cat photos, so let's unpack them. You start by feeding it thousands of your aunt's cat photos. This is the input layer. The network processes these pictures through several hidden layers, adjusting weights and biases along the way, and finally outputs a result. Yep, that's a cat. Or nope, that's actually your Aunt Sally's fluffy hat. Each neuron in the hidden layer analyzes small pieces of the image, edges, shapes, textures, and passes this information on to the next layer. It's like a relay race where each runner is looking at a different part of the picture. By the time the baton reaches the finish line, that output layer we talked about, the network has pieced together enough clues to make an educated guess. So how do you train a neural network? Training a neural network is like training for a marathon. It's all about repetition and fine-tuning. The network starts with random weights and biases, processes the data, and compares its outputs to the correct answer. If it messes up, which it will a lot, it adjusts the weights and biases to do better next time. This process is called backpropagation. But think of it as the neural network's way of learning from its mistakes. Like when you finally figured out that 3 a.m. burritos are never a good idea. But we love Taco Bell. Shout out. Let's look at some real-world applications where neural networks are making waves. So we have things like voice assistants. Siri, Alexa, and Google Assistant are like your AI butlers, your little Ask Jeeves, right? So they understand and respond to your comments using neural networks. You have this little butler on hand 24/7, but without the need for a tip. Self-driving cars. We always use this as an example, but it's a great example of how these components come together, right? Neural networks help self-driving cars recognize stop signs, pedestrians, and cyclists. It's like having a super attentive chauffeur who never gets tired or has intensive road rage. Image recognition. So Facebook uses neural networks to automatically tag you and your friends in photos. You've wondered how that magic happens. Well, there you have it. It's like having your nosy aunt or neighbor who remembers everyone's face, but it's less annoying. Then there's spam filtering. Ever wonder why those Nigerian prince's emails rarely make it into your inbox? Thank neural networks for filtering out the junk. It's like having a digital bouncer who knows not to let anyone with a sketchy backstory in your club. Of course, neural networks aren't perfect. They require massive amounts of data and computational power. Training them can be like trying to teach a cat to play fetch. Possible, but incredibly frustrating. Plus, there's always the risk of overfitting, where the network becomes so good at memorizing the training data that it fails miserably on new data. It's like studying for a test by memorizing the textbook, only to find out the exam is mostly about applying concepts. In summary, neural networks are the backbone of deep learning, mimicking the human brain to process complex data and make predictions. They power everything from voice assistants to self-driving cars, making our lives easier and sometimes a bit more amusing. That's all for today's Neural Network Crash Course. I hope you've enjoyed this deep dive and had a few, maybe laughs along the way. If you've got questions, thoughts, or just want to connect, find me on LinkedIn, Emily Laird, Laird. Let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about neural networks now than you did when you arrived.